Welcome, everyone. My name is Jennifer LeFevre, and I'm the Executive Director of the Electrical Safety Foundation International. Today, I'm joined with my colleague, Daniel Majano, who is the Program Director for ESFI, and together we are going to provide you with an update on the state of electrical safety, which is extraordinarily appropriate because May is National Electrical Safety Month. Next. For those of you who may not be acquainted with ESFI, the mission of ESFI is to reduce electrical deaths, injuries, and fires through public education and outreach, and by being the trusted voice on electrical safety. And as you can see from the slide, there are a number of things that we're committed to in terms of being the leading authority on electrical safety issues. We educate consumers, workers, the media, the communities. We identify new and address evolving electrical deploy needs. We deploy certain safety materials and programs and education so that we can help break technical concepts up into easy safety steps. And we advocate for safety technology, compliance with codes and standards, and risk-reducing behaviors. So for today, what we're planning on doing is giving you an overview as what we're seeing as major touch points for electrical safety, including electrical safety statistics, as well as some information we've gleaned from EV charging surveys, an AFCI GFCI survey, especially what if GFCIs did not exist, and Surge Protective Devices survey. Next. As all of you know, electrification is on the rise, and there's no stopping it. And there's so many things that a lot of people don't realize they come into contact with respect to electrical safety needs. And so what we're going to try to do today is address some of these elements, and especially given that this is only going to get more and more electrified as the years go on. So one of the places that ESFI does a great deal of work relates to electrical safety data, injury and fatality reports that we collect data on every year. And this is information that no one else collects and analyzes in the way that we do. And we take the information, as you can see, from OSHA and the Bureau of Labor Statistics, and it helps us understand who's getting hurt and who's dying on the job. And my colleague, Daniel, will take it from here.
Yeah, thanks, Jennifer. So as Jennifer mentioned, we collect data from both the Occupational Health and or Safety and Health Administration, OSHA, and the Bureau of Labor Statistics. Both data sets provide us a lot of context, a lot of information on why that worker was involved in an electrical fatality or injury. So when we look at the OSHA data, what we did is we went through all 1,600 or so OSHA fatality reports that covered electrical incidences. And we went through all of those, looked through every incident, and tried to find the commonalities between those fatalities. And what we were able to do is this data gives us a lot of context. It lets us know who that worker was, their occupation, their industry, what in a context, in a abstract, to what that worker was doing when the injury or the fatality occurred. While it gives us all that information, there are some limitations. So it doesn't cover workers who are not under OSHA's jurisdiction. So the self-employed and some industries that are managed by other federal entities, like the mining industry, we don't get reports on those. But it does give us a good idea of what's happening across the nation with electrical incidences. And then looking at the Bureau of Labor Statistics, what this information provides is a comprehensive and accurate count of the amount of incidences that occurred. It covers all the United States, and the National Safety Council considers this as a complete count of fatalities that occurred in the United States, specifically to electrical. But it doesn't necessarily cover or provide as much context as that OSHA data or the OSHA reports do. So while we can get a good, accurate number of what's happening, we don't necessarily know what led to that fatality, or it doesn't really give us the context behind the fatality. But it still gives us a good idea of the rate and the numbers of injuries that are occurring. So looking at the trends in general, so we can see that across the board, there was, you can see the number here in red of all workplace fatalities. And this covers all the fatalities across different industries and different causes. And you can see that spike there in 2020 due to work-related COVID fatalities. But if we look at electrical fatalities in that blue line, you can see that the number necessarily, or the chart necessarily hasn't changed so much. We've kind of maintained almost the same numbers over the last 14 or so years. We're not necessarily seeing a drop in the number of fatalities. There was a slight drop in 2024, but in general, we're not necessarily seeing too much of a change. So there is an opportunity to try to raise more awareness across more workers on the potential dangers of unsafe electrical work. So you can see here that there was 1,654 fatalities, according to OSHA, caused by electricity, as opposed to 28,000 or so between the same time period, 2011 to 2024, for all types of fatalities. And then if we look at the rate per 100,000 workers, you can see here for all workplace fatalities, there's an average of about 3.5 fatalities per 100,000 workers. But if we look at electricity or electrical related fatalities, we're at about zero point 0.1 fatalities per 100,000 workers. And again, that number and that rate isn't necessarily changing so much. So even though we're having an increased number of hours worked and increased number of people out in the field in general, we're not necessarily seeing a drop in the rate of electrical fatalities. So if we look at the specific industries, and we're only going to focus on some industries here, we can see that across the board, the construction industry has the highest number of electrical fatalities, according to these OSHA reports. That's followed by administration support, waste management, and remediation services. So that's kind of like a broad category. Then we have manufacturing at 137 fatalities and utilities at 108 fatalities. And if we look a little bit closer into the detailed industries that focus on this, so like detailed industries of those electrical fatalities that occurred in the construction industry, you're going to see mostly electricians, mostly power line workers, and so on. But if we look at the manufacturing, it gives us a different picture. It gives us a much more broad picture. So you can see that most of the detailed industries related to manufacturing are going to be in that kind of like other section. So it's a broad, all different types of manufacturing are having very small numbers of electrical fatalities during this time period. So no one manufacturing detailed industry subsection has a high number of electrical fatalities. But if we look at utilities, we see more of those electrical related utilities. So we're seeing in that the highest number is electrical power distribution at 64 fatalities during this time period. And then we see other electrical utilities like electric bulk power transmission and controls at 14. And then with some fossil fuel electric power generation at 7. So we're not necessarily seeing these high numbers in these detailed industries. It's more of those broad categories that we're seeing the higher numbers in. And then as we look at the occupation involved, so those are the industries, but what type of work was that worker actually doing who were involved in that fatality? So here you can see that electrical occupation, so we broke it down into two ways. We're looking at electrical occupations, so workers who usually work with electricity, who have some sort of level of training around electrical safety, who deal with electricity on a daily basis. So you can see that at the top in the green chart. So this is electrical and electronic engineers, technicians, electrician, power line installers, repairs, apprentices, and the supervisors in those areas. So that's one category that we consider as electrical occupations. And as we go further on, you're going to see how we break it down into how these electrical occupations differ from the non-electrical occupations in the type of fatalities that are involved for those workers. But then OSHA categorizes a number of occupations that face a higher than normal risk of electrical accidents. And you can see those down here. And many of them are electrical occupations. Like you can see the electrical and electronic engineers, equipment assemblers, technicians, electricians. But then a number of them are non-electrical. So you also see like painters and welders and industrial machine operators and material handling equipment operators. So why are those occupations listed here? And why do those have a higher than normal risk? And we're going to go into that later on. So there's a couple of asterisks here on that section at the bottom. And for that, it means that if those workers are involved in a 50 or more volts in a regular work, they have to go through special training. But if they don't deal with any sort of voltage on a regular basis, they don't have to receive any level of training according to this OSHA chart. So here you can see the breakdown of electrical and non-electrical occupations. So if we look at the green section, those are electrical occupations. So you can see that they have a smaller number of electrical fatalities as opposed to those non-electrical occupations that you can see in blue. So in every year, while we looked at this data set, you can see that there were non-electrical occupations had more fatalities related to electricity than those electrical occupations, just purely by numbers. And if we look at the occupations that have the highest number of electrical fatalities, you can see that these five occupations make up for about 50 to 60% of all electrical fatalities that occur in every year listed here. So you can see some of them are electricians, so there are electrical occupations, and then electrical power installers and repair, another electrical occupation. But what about the others? We're seeing laborers, we're seeing tree trimming occupations, and we're seeing construction laborers. So not necessarily workers who receive a level of electrical safety training. They're the ones who end up having a high number of electrical fatalities. And you can see that here again. The blue line is electricians, and the gray one is electrical power installers and repairs. But all the other colors listed here are those non-electrical occupations that I mentioned earlier. So these are making up the bulk of the electrical fatalities every year. And there's a couple of occupations that we've been seeing having an increased number of electrical fatalities. And both of these are occupations that don't necessarily have electrical safety training traditionally, because they're tree trimming occupations and truck drivers who drive heavy trucks. And as we go on, we'll start seeing why these occupations are being involved in electrical fatalities and what's leading to that fatality and what's leading to that or to that injury. And here's a breakdown of the occupations that had 10 or more electrical fatalities between 2011 and 2024. So again, this makes up for a large number of the fatalities that occurred during this time period. And as you can see, there are some electrical occupations listed here, and some of those occupations that were listed in that OSHA chart. So you see like the electricians, the electrical and electronic engineers, you see some painters here also. But looking at the rest of the occupations here, a lot of them are those non-electrical occupations that were also not listed on that OSHA list. See the construction laborers, the tree trimmers, the roofers, the truck drivers, um, carpenters, and farm workers, plumbers. A lot of these trades or a lot of construction related occupations that are being involved in these non-electrical occupations that may not have that level of training. So what is that commonality? What's causing all these fatalities from occurring? But if we look at the rates in general across the board, 2011 to 2024, you can see that the occupations that have the highest average fatality rate during this time period per 100,000 workers is going to be some of those electrical occupations. But all the occupations listed here have a higher than normal risk, have a higher than normal fatality rate related to electricity. So we see that electrical power line installers have 6 fatalities per 100,000 workers, electricians at almost 3 fatalities per 100,000 workers. Then we're also seeing these non-electrical occupations like roofers have a high number here, ground maintenance workers, where the tree trimmers fall into, have a high number here, HVAC mechanics, construction laborers, and painters. All these have the higher than average fatality rate, because what we see across the board, across all occupations, the average fatality rate for contact with electricity is 0.11 fatalities per 100,000 workers, but we're seeing a lot more fatalities in these specific occupations. So what are we doing to combat that? So as an organization, we've released a couple of easy to understand infographics and videos to try to raise awareness on the common causes of electrical fatalities and injuries, but also to empower the workers to know when to say when, know when to stop work, to make sure they're aware of what's around them. So one of the infographics here on the left is something that we remind workers to do before they conduct any sort of job, is to make sure that they're aware of their capabilities, make sure they're aware of their training, and make sure they have the proper training tools, and they performed a risk assessment to make sure that they're capable of doing that job. And if they're not, they should stop and notify their employer or notify whoever to make sure a qualified worker is doing that sort of electrical job. And then on the right, you can see here is a infographic showing about the limited approach boundary for power lines. Because as we go on, we're start seeing what's causing these fatalities and what the commonalities is, and we're going to start seeing how a lot of them are related to power lines. So here it's a reminder of how far to keep away from power lines to make sure you stay safe on the job. And we see how this is going to start applying to like carpenters and roofers and painters because they're going to be the ones, or tree trimmers, and they're going to be the ones who are going to be near those power lines. So here's an example of one of the videos. So we showed the infographics, but this is a video, a short form video, really quick, like under 30 seconds to really just hit these points. This is similar to like a YouTube short or Instagram reel to just try to get that message out there in a very simple, easy to understand way.
Fernando here. Just a quick reminder from the job site. If you're asked to do a task and you haven't been trained or don't have the tools for, it's okay to stop. Seriously, training matters. Asking questions matters. Speaking up matters. Knowing when to say when helps keep everyone safe at work. Safety is smart. Prevention is power.
So looking at the causes, so we know which industries are involved in the most or the highest number of electrical fatalities. And those are the construction industry. Then we know which occupations are involved in electrical fatalities. Those are electrician, construction workers, a lot of the trades. But what are the causes? So as I mentioned earlier, we read through all the OSHA reports. And what we did is we tried to break them down into categories. What sort of commonality did they have? So what we found is we found these commonalities across many of the fatalities. And we're seeing that the number one cause of all electrical fatalities on the job was overhead power line contact. And this is when a fatality specifically was caused by contact with overhead powering or arcing from overhead power lines. But it doesn't necessarily include any sort of other fatalities caused by contact with overhead power lines. But if a worker contacted a power line and then that led to a fall, we consider that as a fatality caused by an overhead power line. Then we have unexpected contact with energy, and that's when a worker's action led to contact with energized equipment or part while working on that specific part. So that could be that the worker didn't test before they worked, or they just didn't realize that energy was on. Maybe they just didn't lock out tag out correctly. Then we see nearby energized equipment contact, and this is when a fatality occurred when the worker came in contact with something that's energized around them. So in most of these cases, it's like their tool came in contact with something that's near them in a confined space, and that equipment that was near them was energized, and that led to the fatality. Then we have working on energized parts, and this is when a worker specifically mentioned or specifically worked on an energized part. So they knew the parts were energized, and they decided to work on it, and that led to the fatality. Then we have ground faults, and that's specifically a ground fault related fatality. In many of these cases, it was a construction worker working outside and plugging into a non-GFCI protected outlet. I would say it's probably 99% of the fatalities that fall into this category were that. Then we have damaged equipment or wiring, and that's when the specifically damaged equipment or wiring led to the fatality. We have arc flashes, and then we have an other section. And that other is a very small percentage, and it includes workers that were troubleshooting or testing, a worker mistake, underground power line contact, a lockout tagout procedure failure, backfeed, electrical fires, and improper installations also. So how does this break down across all occupations? So we're seeing that 49% of all workplace electrical fatalities are caused by contact with overhead power line. The next highest number is unexpected contact with energy at 20. Nearby energized equipment contact at 12, working on energized parts at 4, ground faults at 4, damaged wiring or equipment at 3, arc flashes at 2, and then the whole other category at 6%. But we'll see how this is different between all different types of occupations. So this is across the board for all occupations. But what about electrical occupations? So what we were seeing before was 49% of overhead power line. 49% of fatalities was caused by overhead power line. But in looking at this, we're seeing that for electrical occupations, overhead power line contact is only 27%. But we're seeing a higher number of unexpected contact with energy. We're seeing a higher number of working on energized parts. We're seeing more arc flashes. We're seeing more in that other category. But we're not necessarily seeing the same that we were seeing across the board. But if we look at non-electrical occupations, the numbers start shifting again. So for non-electrical occupations, 57% of all the workplace fatalities are caused by overhead power lines. So the majority of fatalities for non-electrical workers are caused by overhead power line contact. And then we're not necessarily seeing so much unexpected contact with energy or not so many nearby energized equipment contact, not so many working on energized parts, not so many arc flashes, but we are seeing more ground faults. So as I mentioned earlier, a lot of those are like the construction workers working outside and not necessarily having the right equipment or the right ground fault protection when they're working outside. So here's a video that kind of covers this overhead power line contacts for non-electrical workers.
Overhead power lines cause 40% of all electrically related fatalities in the workplace. A majority of these accidents occur with workers who have little to no electrical safety training. That's why it's important to always look up before doing any kind of work on a construction site. It could save your life. If my buddy had raised the bed into that power line, both the line and the truck would be considered live and dangerous. Now, if you see equipment in contact with a power line, it's not time to be a hero. You need to stay away. Warn others to do the same. You should stay at least 35 feet back. It's about 2 dump truck lengths. If conditions are wet, you may need to move away even further. If you're inside the vehicle, stay inside. Warn others to stay away and call 911. Do not exit the vehicle unless you see smoke or fire. Now, if you must exit the vehicle, do not touch the ground in the vehicle at the same time. You must jump from the vehicle and land with both feet together. Then, avoid lifting your feet as you slowly shuffle away from the down power line and the vehicle. Remember, if you see a down power line, stay away, call 911. But to avoid major accidents like this in the first place, be sure to always look up in all ways.
Now that video was filmed maybe about 4 to 5 years ago, and we were seeing 40% of fatalities being caused by overhead power line. That percentage jumped up to 49% now. So there's a significant change during that time period between 5 years ago and today. So we know what's the leading cause of electrical fatalities. We know which occupations are involved, which industries are involved. But now we'll take a look at workplace electrical injuries. So specifically injuries that involve days away from work, but they did not lead to a fatality. And the way that the Bureau of Labor Statistics breaks this down is by 2 years at a time. So we're going to be comparing 2021 and 2022 to 2023 and 2024. So here you can see the number of non-fatal injuries involving days away from work during these time periods. So we're seeing almost a double jump from 21 to 22 to 23 to 24. So we're seeing an increased number of non-fatal electrical injuries occurring on the job. And if we look at which occupations or which industries which occupations have the highest number or highest rate of electrical injuries, we're seeing a difference in the fatalities. So with the fatalities, we're seeing a lot more of this construction. But now in looking at the injuries, we're seeing a lot more of installation maintenance and repair occupations having a higher rate of electrical injuries. So we're seeing a difference there between the fatalities, which are construction workers, construction and extraction occupations, but then the injuries, we're seeing a lot more in that installation maintenance and repair occupations. We're still seeing a high number of construction, but not to the same rate that we were seeing the fatalities. And if looking at how long the worker was working at that specific employer, not necessarily in the industry, but that specific employer, when the fatality occurred, if we look at that green line, which covers the most recent data set, we're seeing that a lot of workers have been working there for quite some time when the injury occurred. So 2,160 of those workers who are involved in non-fatal electrical injuries involving days away from work were working at their employer for 1 to 5 years. So there's a chance that it could be like a complacency issue, something that maybe those workers feel like they've done that job a million times, and that's why the injury occurred. If we look at the time that a day it occurred or what day it occurred, we're also seeing like towards the end of the week and towards the beginning of the week. I don't have a graph for that, but the number of number of non-fatal injuries, a lot of them occur on a Monday or a Friday. And then if we look at the total or the median number of days away from work, we're seeing that that time period of 23 to 24, we're seeing the median days away from work was 10 for a non-fatal injury. So that's a long time that worker has to be away. That's a long time that they're possibly in the hospital, thankfully for a non-fatal injury, but some of these injuries could cause lifelong injuries and lifelong disabilities. But we're also seeing the median number of days away from work jump from 5 in the last data set to 10 in the most recent data set. And here's another video that kind of summarizes a lot of these fatality numbers and injury numbers.
Working with electricity, it's extremely dangerous. So it's important to always hire qualified electrical workers for those jobs. At the workplace or job site, 69% of all electrical fatalities involve non-electrical workers. Overhead power lines, unexpected contact with electricity, working on energized parts, ground faults, and damaged wiring accounted for 92% of electrical fatalities. Avoid catastrophe by knowing when to say when. If you feel unsafe performing a job, stop and say something. Avoid electrical rooms and other potentially dangerous areas. Make sure GFCI protection is installed where electricity and water may come into contact. And always look up before performing a task outside to avoid power lines. Be smart and stay safe.
So if we look at the leading causes of electrical fatalities, we can see that overhead power lines accounted for 49% of all the fatalities. And we can try to reduce these injuries and these fatalities that are caused by overhead powering by increased messaging. So you can see power lines. They're visible. We have to remind workers that whenever they're working outside or anywhere, to always look up in all ways to ensure there's no power lines around them. And then if we're looking at the industries with the highest number of electrical fatalities, we can see it's the construction industry. So we're seeing that 51% of all fatalities were in that construction industry. And if we look at all occupations, all industries, we can see that 70% of fatalities that were caused by electricity were in non-electrical occupations. So workers who don't necessarily have a level of electrical safety training. So it's really important that if there's work around electricity or work involving electricity, to make sure it's a qualified worker that's doing that job.
I'll also add here that we have resources for those who may want them in terms of always look up in all ways. We also have a lot of all this data is also available from our website, and it's something that is very much in demand. For those of you who may be aware of the IEEE Electrical Safety Workshop, this data, Daniel has won several awards for his comprehensive analysis of this data year over year, including an award this year. So it's something that you're not going to find anywhere else in terms of the analysis that we do and the data that we have available from our website.
And moving on, so we looked at electrical fatalities and electrical injuries, but as an organization, we do try to find a comprehensive view of electrical safety in general across all sort of industries and also for consumers and for building owners. So what we did is about a year or so ago, we surveyed a number of EVSE owners, building owners that have EVSE installed, and installers of electrical vehicle supply equipment to understand their knowledge on how to safely charge and to understand what the consumers and what the general public knows about charging in general. So what we saw is that 72% of EVSE installers were certified electricians. So not everyone who was installing EVSE was actually an electrician or have that level of certification, even though 82% of the installers believe that there should be a specific certification to install EVSE. And we're seeing about 76% of them receive specific EVSE installation training. And that we're seeing that almost a quarter of them have often or always encountered safety concerns when installing EVSEs. So we're seeing like a decent number of safety concerns and a decent number of installers who may or may not have a level of training to install the EVSE safely. And looking at the building owners, we're seeing that almost half of the building owners had to have maintenance performed on the EVSE, so the electric vehicle supply equipment that they own or manage. And here on the right, you can see who performed that level of maintenance, and about half of them had a electrician do that maintenance, but a lot of them also had handymen or building staff do that level or do maintenance on that EVSE. So maybe those workers were qualified, but maybe not. We don't necessarily know because, we say that a qualified worker should be doing that work, but there's a chance that because they're at the level of work that they're doing these titles, they may not have that level of specific electrical safety training to do this job safely. And then looking at, again, building owners, have they had to replace any sort of EVSE equipment? We're seeing about 20% of them say yes, they did have to replace equipment because it was damaged. And here on the right, you can see what sort of equipment they had to have replaced. So many of them were the cables, the plugs, and connectors, but not so many of the meters or the overcurrent protection. But you can see that here on the right. And we're seeing about 8% of homeowners have received shock when they're using their EVSE or when they're charging an EV. And then we're seeing about 22% had to reset a GFCI when they were charging their EV. And if looking at adapters, we're seeing that 23% of homeowners had to use an adapter because they weren't able to find the right type of charger for their specific car. And then almost 50% had to buy an adapter to charge their EV. Now, this could be a concern because if that adapter is not approved by the manufacturer, if that adapter comes from an unknown source, if that adapter doesn't have any sort of certification on it, that may disrupt that handshake between the car and the charger and lead to an issue down the line. It could lead to shocking or fire or maybe damaging the battery also. So it's really important that any sort of we try to raise the importance to those consumers and those homeowners that if you're buying any sort of electrical equipment, including adapters for their EV or their EVSE, that they make sure that they're sourcing it from a reputable retailer, that they understand what certifications mean, so like NERDL certification, looking out for those symbols, and making sure that they're having a qualified installer, qualified worker install those devices. And then here you can see how often the homeowners were using EVSE adapters, and you can see about 15% of them had to often or always use an adapter when charging, while about 50% said sometimes they have to use an adapter. So looking into more of the safety devices that are required in the National Electrical Code. So over the last few years, we've worked to find a performance of AFCIs, GFCIs, and surge protected devices. And what we did is for AFCIs and GFCIs, we looked at a survey on their performance. So we surveyed electrical contractors in these states, Colorado, Georgia, Kentucky, Montana, Ohio, Texas, and Washington. And we asked them, how often are you getting service calls related to breakers? What sort of work are you doing at homes related to breakers? What sort of faults are you seeing? Are you seeing the proper type of protection installed in circuits and so on? And what we're seeing is that 48% of electrical contractors were called to or had service calls that involved a trip breaker or fuse. And we're seeing that 100% of those contractors, when they were working on a AFCI related service call, they saw evidence of dangerous arcing. So pretty much what we see here is we're seeing the AFCIs work. We're seeing that every time a contractor went to go service an AFCI, 100% of the time, there was a sign of an arc. So we're seeing that this device is working. And if we're looking at what sort of breakers are breaking at what rate and why, you can see here the breakdown of what those contractors said. So standard circuit breakers had 30%, fuses at 24%. The remainder at those GFCIs, AFCIs, and dual functions are not necessarily seeing the same rate of tripping as those other devices. And we're seeing that only 37% of contractors said that service calls involved circuits that had the the correct type of protection installed. So we're seeing that there's a lot of disconnect there. And one of the things that we also looked at in the same survey is to find out why those standard breakers were tripping, or why a lot of breakers were tripping, and a lot of the tripping was involved because of circuit overloads. So it seems that sometimes either the homeowner didn't necessarily understand the demands that their home had on certain circuits, or their home just wasn't capable of handling that level of energy drawn in the current state. So maybe they had to get more circuits installed, maybe they had to have more outlets installed, and that was why those circuits breakers and those other types of breakers were tripping. And then looking at AFCIs, what we did is we did an analysis of finding out how have GFCIs protected homeowners, consumers, general public since their adoption in the 70s. So what we're seeing here is between 1975 and 2020, or 2020, we saw a 93% drop in consumer product electrocutions. Many of these can be attributed to GFCIs and GFCI protection. And here you can see the chart. You can see GFCI protected homes in that light blue color. You can see the consumer product electrocutions with GFCI protection in the green line. You can see electrocutions in general, so not just consumer products, just all electrocutions with GFCI since the adoption of GFCI protection in that yellow line. And then you can see that we ran an estimate of consumer product electrocutions and an estimate of electrocutions that could have occurred if GFCI protection was not invented. And you can see those in the remaining lines there. So that in that silver line and that purple line. So pretty much what we're seeing is that GFCIs have been working. They dropped that 93% of consumer product electrocutions. And then looking at surge protected devices, we also surveyed industrial and commercial facility professionals to find out what they know about surge protection and what sort of damage has surges, voltage surges, contributed to their facilities. And we're seeing that 33% of respondents said that there was a downtime of an hour or more due to a voltage surge. And what we're seeing is that the average cost per downtime was over $6,000 per hour. So we're seeing that these surges not only can damage equipment, but they can also cause costly downtime at facilities. And we're seeing that it's not just older equipment being involved or being damaged by these voltage surges. We're seeing that 67% of the respondents said that the equipment damaged by these surges were less than 5 years old. And then when we asked them what causes the surge and what protects against the surge, we're not necessarily seeing that the education's there to understand what causes the surge and what protects the surge. So you can see that a number of them on the left chart here said that sustained overvoltages in a direct lightning strike can cause a surge. And on the right, you can see we asked them also what protects against the surge. And many of them said the standard, typical power strips, properly installed wiring, ground fault, UPSs and fuses and breakers can protect against surges. But surge protective devices protect against surges, not necessarily these devices. They can't protect against a sustained overvoltage that leads to, an overvoltage that leads to a surge. And we can see that 37% of surges were caused by factors inside the facility of those people who we surveyed. So it's mostly those large electrical equipment turning on and off, faulty wiring, and static electricity or static electric discharge, causing those surges inside the facility. And we try to raise this towards homeowners also to let them know about whole home surge protection, protecting those valuable electronics in their home, like computers, TVs, refrigerators, HVAC systems, and so on. So that leads us down to the conclusion. That was a lot of information on workplace safety, a lot of evidence showing that how AFCIs and GFCIs work. So we'll just give a quick summary of this here. So we see that. Yeah, go ahead. No,
you finish. So essentially, the information that we have here, where everything's continuing to be more electrified, and that's going to continue to grow exponentially in the near future and beyond. And it's important that we understand why electrical fatalities are happening, what we can try to do to staunch that. We also have to understand, why people are also getting hurt. And we're also going to need to make sure people are trained to be able to come into the industry and are trained to be able to continue with the next generation of electricity and all the different things that use it. As you can see from this presentation, there's a lot that we do. As I mentioned at the very beginning, we are celebrating National Electrical Safety Month, and we do have a great deal of resources related to that. You can find a lot of our materials on our website, esfi.org, including information about our specific materials for National Electrical Safety Month for this year, as well as the videos that you saw, some of the other materials that we have with infographics. And it's also important that it's, for not just for the workplace, but for the home too. And please, these materials are free to use. Share them as much as you possibly can. Share them with your families, your colleagues, your communities. You may just very well save somebody's life by helping for them to understand what risks there are and to help people make safer choices. Again, these are some of the different things that we're working on in terms of understanding what different EVSE folks and what GFCIs, AFCIs. There's also something that's really important. Some of you may be aware that there's an attack in some states to try to make changes to the National Electrical Code, where they might not want to have certain GFCIs required in certain elements of homes. And you can see from the data that we have, GFCIs and AFCIs have been extraordinarily helpful in helping to save lives, and they're working the way they're intended to. So if you want to use any of our materials for work you might be doing to help save certain aspects of the National Electrical Code in your states, you're certainly welcome to use our materials for that purpose as well. And again, May is National Electrical Safety Month. We have all of our resources. There's also materials that you might see on our socials, so please follow us on our socials and share and comment on those posts. And certainly feel free to share them among your own socials as well. Certainly the more people who are exposed to this information and realize what resources we have available, the better. And certainly if you have any questions, you can certainly, we'll take some questions here, but we also have our contact information available on the next slide. And you can certainly reach out to us if you wanted to ask something more specific than just what you might ask for here. We'd be more than happy to answer those questions. We will make these slides available for those who might be interested. I know someone asked about that. And we will entertain questions right now, and I'll just go ahead. Somebody has asked about how often the data that we were talking about earlier comes out, and I'll let Daniel address that.
Yeah, so the data is released yearly from the Bureau of Labor Statistics. But for the OSHA data, that's on an ongoing basis right now. And we haven't necessarily seen the data that has been released over the last year or so, but we do a yearly data collection, which we should have an analysis done sometime this year. And hopefully we should have the next set of data available through 2025 at the start of 2027.
Great, thank you. Yes, this presentation is being recorded and it will be available to the public for free. So you can certainly feel free to share that link as well. And it'll be on NEMA's NEMA Academy. And so anybody who might be interested in these statistics, they're very helpful. They help us direct where our resources should go when we understand how people are being injured on the job. So so as I mentioned earlier, we do have an always look up decal logo that people can use. I know a lot of people use that as a hard hat decal, and we'd be more than happy for you to take that and provide it to anyone who might be willing to use it. Also, there's a question regarding what else we have coming down the pike, and we do have some interesting things that we are looking into, which I will again toss over to Daniel.
Yeah, so later this year, we're going to launch an area where people can report near miss incidences. And I think looking at near miss incidences or close calls is going to give us an idea of what the industry is doing right. We're going to be able to see what sort of training works, what sort of like notifications work, what sort of tools work, what sort of our flash protection works, and hopefully we'll get an idea of what's working and seeing how we can implement that into a broader picture. And then if we're looking at things that are currently occurring, those near misses that are occurring on like now, we should be able to work towards bettering those areas as opposed to looking at just those lagging indicators, which are those fatalities and those injuries. Because we're seeing that in many cases where an injury or a fatality occurred, there was many close calls incidences that were like the precursor to that fatality or to that injury.
There are some additional areas too where we're continuing to broaden our reach. With respect to data centers, the main things that we underscore with respect to data centers are that as long as data centers are built with products that are nationally recognized testing laboratory certified and with safe products, as long as they're built by qualified workers and that they're maintained the way they should be on a regular basis, then data centers are safe. And it's just making sure that those very important elements are met where we ensure that data center safety. And to Daniel's point about near misses, also to making sure that people understand Even people that are, maintenance crews, like cleaners, know where they can go, where they couldn't go, or the things that they may need to know specifically for something like that. We'll be highlighting at some point, because not everybody, data centers obviously have to be clean, but not everybody necessarily understands what they need to do in certain circumstances. I do also want to mention that some of our resources are also in other languages. Certainly, we didn't mention it here, but Hispanics often have a higher rate of electrical fatalities as well. And sometimes it's just a matter of having materials that are in Spanish that might help in that area. We don't actually have our own training that we do, but a lot of people do utilize our resources as part of their own training programs. So for example, having just one of the video shorts helps kind of break up some of the training programs that you have. And then certainly the infographics that we have, you could certainly print out and use as part of your training programs as well. So that's something else that we have for anyone to use. Again, all of our resources are free. Also, too, for those of you who are out in the field, if you see something that's electrically related that you think ESFI should look into, or perhaps investigate as preparing some new resources on, we'd certainly love to hear about that. We get this data from a variety of sources in terms of where we're trying to put our resources, but you might be seeing something, a trend that we've not recognized yet. So we'd certainly invite anyone to stay in touch with us and let us know what you're seeing. Are there any other questions? Well, we appreciate everybody participating today. Again, this recording will be made available, as will the slide deck. And then if you think of any other questions that you may have later on, please feel free to reach out to Daniel or myself and any of the other ESFI team members. Okay, thank you.
Thank you.